This year's Nobel Prize in Physics was awarded to the following three people. But in this video, I'm going to talk about Arthur Ashkin's invention of optical tweezers. Optical tweezers are things that use a laser beam to physically hold and move microscopic objects. They can trap and manipulate small particles. But the question is how? Let us take this bad boy. This bad boy is a micron-sized dielectric particle, which means it is an insulator and can be polarized by an applied electric field. Let's put him in a laser beam. Diameter of this bad boy is significantly greater than the wavelength of light. If we place him in the middle of the beam, he is perfectly comfortable, but displacing him from the center will cause a net force to act on him toward the center. Apparently, he likes to stay in the denser part of the laser beam, and this is what traps him. Think of it this way: our bad boy has some kind of shield which he uses most effectively if he blocks the intense part of the beam. So he likes to stay in the center or his sides would get burned. But let's do some actual physics. This trapping can be explained using ray optics. Rays of light emitted from the laser will be refracted as it enters and exits this dielectric body. Because of this, ray will exit in the direction different from which it originated. Since light has a momentum associated with it, this change in direction indicates that its momentum has changed. Due to Newton's third law, there should be an equal and opposite force on the buoy. The particle has a net force returning it to the center of the trap because more intense beam imparts a larger momentum change toward the center of the trap. The net momentum change or force returns the particle to the trap center. But this traps our buoy in the center of the laser. For instance, in this case, it can still move up and down. We need a focus laser to keep the bead in a fixed axial position. This can be done using an objective lens. So now if this bead moves forward, the momentum change of the focus ray will cause a force toward the laser focus. So this buoy will stay slightly behind the focus, where this force compensates the scattering force.